Good morning friends. Today we are going to discuss about a dihybrid cross. Last class we are talking about monohybrid cross. It's a cross between two plants differing one set of characters. Now we are going to discuss about dihybrid cross. It's a cross of two plants differing in two set of character, which is also called dihybrid hybrid. Di means two. Two set of characters we are differing in this plants. So through that, Mental proved his law of independent assortment. So the gamete formation, the paired gene of characters are sort out independently one another. Pair. So two character, one is color and shape. Color of the color of this one, okay, and the shape. So are considered at a time. So the cotyledon, they have a yellow and green. So the dominant character is yellow and recessive character green. And the seed shape, which is round and wrinkled. Round is dominant, wrinkled is recessive. Our pea plant has a two characters, two set of characters. Color of this cotyledon and shape of this seed. So yellow and this green and round and wrinkles. So Mental selected pure breeding yellow round, producing a plant, another pure breeding with green and wrinkled seed producing plants. So two plants were treated as a parents, were crossed, cell crossed. So F1 generations, the plant it produced only yellow round seeds. So F1 plants were self-fertilized. So the cross of two plants differing in two character. For this proving his experiment, so he selected color of this cotyledon and shape of this seed, yellow, yellow, green, round and wrinkled one. So through that, Mental proved law of independent assortment. Next, so the F2 generations, so they are produced four kinds of plants, gametes which is produced. Plants, they are producing yellow round seeds. Plants producing yellow wrinkled seeds. Plant producing green round seeds. Plant producing green wrinkled seeds. So after completing of this F2 generation, the similar yellow round plants and green wrinkled plant, two set of character, they are able to produce four set of offspring, or it's young one they produce. Plant they can produce yellow round one, and plant which can produce yellow wrinkled seeds, plant which can produce green round seeds, plant which can produce green wrinkled seeds. So the phenotypic ratio is 9:3:3:1. The genotypic ratio is 1:2:1, 4:2:1, 2:1. So this is a genotypic ratio of this dihybrid cross. So parent here, I am write it round and yellow and wrinkled and green. Okay, so the gametes capital R, capital Y, and this here small r and small y. The F1 generation will get us capital R and small r, capital Y and small y, round yellow. So F1 it's tossed capital R, small r, capital Y and small y. Similarly, capital R, small r, capital Y and small y. So the gametes which will get it capital R, small capital Y, capital R, small y, small r, capital Y, and small r, small y. Similarly, we'll get it here also. The phenotypic ratio 9:3:1, and genotypic ratio 1:2:1, 2:4:1:2:1. So we'll move to this checker pose. So the parent round yellow, it is wrinkled green. Some textbook it is written yellow round, green wrinkled. It is also okay. Okay, it is similar. It's no problem. So here round yellow, round it is symbolized capital R, wrinkled it's mentioned as capital Y. Wrinkled it's mentioned it as small r, and it is green mentioned it as y, small y. So gamete which will get it capital R and capital Y. Here wrinkled green will get it small r and small y. So F1 generation, when we cell pollinate, capital R, small r, and capital Y and small y, which will get it in the F1 generation round yellow. So when we in the F1 generation, which is intercrossed, okay, or crossed with this one, capital R, capital Y and small y. Similarly, capital R, capital Y and small y. So we'll get it 4 type of gametes. So capital R, capital Y, small r, capital Y, capital R, small y, and small r, small y. So we'll get it things when we cross between these parents, capital R and capital R, capital Y, we'll get a round yellow. Similarly, capital R and small r, capital Y and small y, round yellow. So similarly, we'll get this parental to offspring character, yellow round, round yellow, okay, and round yellow, okay, round yellow, I will get it, and wrinkled yellow, okay, round green, wrinkled green, we'll get it through dihybrid cross. Dihybrid cross, it is prove this independent assortment law. So it's a 2 set of character when we cross between them. Next, we move to what is the difference between monohybrid and dihybrid cross. Monohybrid cross, which is involve single parent. Dihybrid cross involve 2 different parents. Monohybrid cross can produce single progeny. So dihybrid cross can produce 2 progeny. Monohybrid cross involves organisms that are heterozygous for a single characters. Dihybrid cross involve the organism that are heterozygous for 2 characters. Monohybrid cross, it is performed only once. Dihybrid cross performed twice. Monohybrid cross result 3:1 and dihybrid cross 9:3:3:1. And their monohybrid cross genotypic ratio is 1:2:1. Here 1:2:1, 4:2:1, and 2:1 ratio. So monohybrid cross, it can prove this law of dominance and law of segregations. Dihybrid cross, it can prove law of independent assortment. Okay, so now it is over. Thank you for watching this video.